Hello everyone. Today we will be discussing probability distribution. Discrete random variables take only a finite or countable number of values. There are several useful discrete probability distributions, but we will only learn today binomial probability distribution. The binomial random variable. The coin tossing experiment is a simple example of a binomial random variable. Toss a fair coin 3 times and record x, which is equal to the number of heads. We have this table where x are the number of heads and the probability of getting a 0 head is equal to 1/8. The probability of getting 1 head is 3/8. The probability of getting 2 heads is 3/8. And the probability of getting 3 heads is 1/8. It can be shown through this chart by plotting along the x-axis the number of heads and along the y the probability of getting those heads. Many situations in real life resemble the coin toss, but the coin is not necessarily fair, so that the probability of getting a head is not equal to 1/2. Example: a geneticist samples 10 people and counts the number who have a gene linked to Alzheimer's disease. The coin represents the person, the head represents those who have genes linked to Alzheimer's disease, the tail represents those who doesn't have the gene linked to Alzheimer's disease, the number of tosses represents the 10 people, the probability of getting a head represents the probability those who have genes linked to Alzheimer's disease, which is equal to the proportion in the population who have the gene. Let us try out if these examples are binomial or not. Example 1. A certain surgical procedure has an 85% chance of success. A doctor performs the procedure on 8 patients. The random variable is the number of successful surgeries. N is equal to 8, which are the number of patients. The random variable x is less than or equal to 8. The probability of success is equal to 0.85. The probability of getting a failure is equal to 0.15. Of course, this is a binomial experiment, since we have 2 possible outcomes. Let us have another example, and let us tell again whether it's a binomial or not. For example, you take a multiple choice quiz that consists of 10 questions. Each question has 4 possible answers, and only one of which is correct. To complete the quiz, you randomly guess the answer to each question. Let n be the number of questions, that is 10. X is less than or equal to 10. The probability of getting a correct answer is 0.25. Since there are 4 possible answers, then the probability of getting a wrong answer is 0.75. It is also a binomial experiment since there are 2 possible outcomes, that is, getting a correct answer and getting an incorrect answer. Another example. A jar contains 5 red nips, 9 blue nips, 3 green nips, and 2 yellow nips. You randomly select 3 nips from the jar without replacement. The random variable represents the number of red nips. It is not a binomial experiment. Why? Because there are more than 2 possible outcomes. The binomial probability distribution. For a binomial experiment with n trials and probability p of success on a given trial, the probability of k successes in n trials is given by the combination of n taken k at a time times p raised to k times q raised to n minus k, for k is equal to 0, 1, 2, till n. But we must also recall the formula for getting the combination. That is, the combination of n taken k at a time is equal to n factorial over k factorial times the quantity n minus k factorial, with n factorial equals n times n minus 1 times n minus 2 until 2 times 1 and 0 factorial equals 1. The mean and standard deviation. For a binomial experiment with n trials and probability p of success on a given trial, the measures of center and spread are the population mean equals n times p, where n is the number of trial and p is the probability of success. The population variance is equal to n, p, and q, where n again is the number of trial, p is the probability of success, and q is the probability of failure. The population standard deviation is equal to the square root of n times p times q, or simply the square root of the variance. Let us have this example. A marksman hits a target 80% of the time. He fires 5 shots at that target. What is the probability that exactly 3 shots hit the target? N is equal to 5 because he fires 5 shots at the target. Success is the number of hits. Probability is equal to 0.8 since it is 80%. And X is equal to exactly 3 hits. The probability of X is equal to 3 is equal to the combination of 5 taken 3 at a time times p raised to 3 times q raised to 5 minus 3 is equal to 5 factorial over 3 factorial times 2 factorial multiplied by 0.8 raised to 3 times 0.2 raised to 5 minus 3 is equal to 10 times 0.8 raised to 3 times 0.2 raised to 2 is equal to 0.2048. What is probability that more than 3 shots hit the target? The probability of x greater than 3 is equal to the combination of 5 taken 4 at a time times p raised to 4 times q raised to 5 minus 4 plus the combination of 5 taken 5 at a time times p raised to 5 times q raised to 5 minus 5 is equal to 0.7373. We also have what we call cumulative probability tables. You can use the cumulative probability tables to find probabilities for selected binomial distributions. First, we have to find the table for the correct value of n. Second, find the column for the correct value of p. And find the row marked k gives a cumulative probability. Probability of x less than or equal to k is equal to the probability of x equal to 0 plus until the probability of x equals k. Example, what is the probability that exactly 3 shots hit the target? We have this table again for k from 0 to 5, and the probability is equal to 0.8. Now let us locate the 0.80 column. Take note that in each row changes the number of k given the cumulative frequency. Therefore, we get the cumulative probability for k is equal to 3 and k is equal to 2. There. And that is 0.263 and 0.058. Subtracting these two values, we get 0.205. Check from the formula. That 0.205 is very close to 0.2048. And we also have to consider this problem. What is the probability that more than 3 shots hit the target? Again, we have this cumulative probability table. Since it is more than 3 shots, it is simply 1 minus 0.263, which is equal to 0.737. Check from the formula. It is equal to 0.7373, which is very close to 0.737. Would it be unusual to find none of the shots hit the target? So, what is the probability that x is equal to 0? Is equal to the probability that x is less than or equal to 0 is 0. What is the probability that less than 3 shots hit the target? The probability of x less than 3 is equal to the probability of x less than or equal to 2 is equal to 0.058. What is the probability that less than 4 but more than 1 shots hit the target? The probability of x greater than 1 but is less than 4 is equal to the probability of x less than or equal to 3 minus the probability of x less than or equal to 1 is equal to 0.256. Here is the probability distribution for x, which is equal to the number of hits. What are the mean and standard deviation for x? Population mean is equal to 4. Population standard deviation is equal to 0.89. There you go. That ends our lesson for today. Thank you for watching. See you around.